Hello, welcome to the new AP Computer Science A series, Unit 5 on Writing Classes. If you want to jump ahead to a specific topic, check out the time markers in the video description. Also, I will be adding to and updating this series, so make sure to hit the subscribe button to keep up to date on all the latest content. We'll start this unit by learning the basics of writing classes and using objects. In place of the term object, I may say instance of a class or instance. All mean the same thing. Example of languages that use an object-oriented paradigm: Java, C++, C#, and Python. There's many more, but these are four major ones. So what is an object? In object-oriented programming, objects have the following. They have states, and we do that with fields in Java, and they have behaviors, and we do that with methods in Java. So let's take an example of a real-world object that we might want to represent in programming. So this dog has states: color, is it awake, and its age. And the dog also has behaviors like bark, run, and eat. The states would be represented by fields, the behaviors would be represented by methods. What is a class? A class is a blueprint or a template for an object. So I use this picture as an example. This is not an actual car, but it's a blueprint or a template for the car. Now, there are certain behaviors in Java that we can access without creating the object. We can do it simply from the class. And these are static methods in Java. And we know they're static methods because they have the word static there. For example, we can rotate the wheel in this blueprint. We can open the hood in this blueprint. That's why these are static methods. We don't need to create the actual car to use them, though we could use them on an actual car. Now, non-static methods. These are behaviors that we can only access from an object. In Java, we call these non-static methods, and they don't have the word static, so that lets us know they're non-static methods. If we want to turn on the engine, we actually have to create a car from the blueprint. We have to create an instance of the class. Same thing with drive. We have to create an instance of the class and apply drive method to it. All right, so let's talk about class variables. Now these are static fields, and these are states that belong to the class. In Java, we call these class variables or sometimes static fields. Understand, if you change a class variable anywhere, you change it everywhere. So if we change the wheel size anywhere in any instance or the class itself, it'll change all instances. So if we change the wheel size in one place, since the wheel size belongs to the class, it changes it everywhere. Same thing with vehicle type. We change it one place, it gets changed everywhere. We also have instance variables. And these instance variables, also called non-static fields, we can't give them an actual value, or they don't have an actual value, until we create an instance of the class. So we can lay out what their value will be, but we can't access that value until we create the instance. So in Java, we call these instance variables, also known as non-static fields. Only an object may have a value for the instance variables, though, like I said, we can set out what the value will become in the class. And changing the values in one object does not affect other objects. So here's an example of some instance variables. They don't have the word static, so we know they're instance variables: color and license plate. And if we change these in one place, they only change for that particular instance. So additional notes. A static method can only access class variables. A non-static method can access class variables or instance variables. And you notice we had the private keyword on our fields. What that does is that makes it so the fields can't directly be accessed by other classes. That helps us prevent bugs, and it also helps us get a top score on an AP free response question. Here's some sample class code. So for our class Audi A8, we've got private static int wheel size. This is a class variable. It belongs to the class. This is an instance variable. It belongs to the instance. Private string color. Then we have some methods. I didn't actually put the code inside it to save space. Private static void rotate wheel. This is a static method, so we don't have to create an instance to use this. We've got public void turn on engine. This is a non-static method. We can only call this from an instance. And then there's going to be some getter and setter methods that are not shown. All right, here's some more sample code about how we might use the APCSA class. So we've got our main method. Here, I'm calling rotate wheel. I'm calling it from the class. This is legal to do because rotate wheel is a static method. Here, I'm declaring a new variable called Jane's car. The variable is of type APCSA, and we're creating a new object, and Jane's car has a pointer that's pointing at that new object. Then we're calling Jane's car rotate wheel. Even though rotate wheel is a static method, we can still call it from an instance. And then we're also calling start engine. Start engine is a non-static method, so we can only call this from an instance. Some additional notes. The private static int wheel size is a class variable. Private string color is an instance variable, and we know that because static means it's a class variable. No mention of static means it's an instance variable. If we make a change to wheel size, since it is a class variable, it will change the value everywhere. And if we make a change to color, which is an instance variable, it will only change the value in one instance. That concludes a basic overview of what classes are and what objects are in Java. Now let's talk about declaring methods. Here's a sample method. First up here we have the method header. And then we have the curly brackets that show us where the method body begins and ends. Let's take a look at the method header. The first part is the access modifier. The two most common access modifiers in Java are public and private. Public means we can access it from inside or outside the class, while private just means we can only call it from inside the class. Next, we have this where it says static. Now a method can be static or non-static. If it's non-static, we just leave this part here blank. We'll learn more at another time what it means to be static or non-static, but the two key things are whether a method is static or non-static controls what fields the method can access, and also how the method can be called. Next, we have the return type here. So we could have a void return type, which means the method returns nothing. And if it's a void return type, that means the return statement's optional. A return statement in a void return type method will just end the method early. Now, there's a number of other possibilities. Any primitive or any object type could be the return type. And that just means we have to make sure that when the method ends, it returns a piece of data of the proper type. Next, we have the method name here. A method in Java should be descriptive of what it does, and it also should be written in lower camel case. And then here we have the parameters. Now we don't need to have parameters. It could just be a simple open closing parentheses. We can have one parameter, we can have multiple parameters. The purpose of the parameters are to pass data to a method. So if we call sample method, we have to pass it one int followed by one string. And those pieces of data will go into the variables x and y respectively. When we have multiple parameters, we need a comma separating them. You may notice that there's two different places people put the opening curly bracket. This here, where it opens on the next line, is part of the Ullman indentation style. Whereas when the opening curly bracket is on the same line as the declaration, that's part of the KNR indentation style. So there you have the basics of declaring a method in Java. In this Java tutorial, we're going to be learning about getter methods and setter methods. These are also called accessor methods and mutator methods, respectively. In this video, we're going to learn about four things. First, we're going to review field variables. Second, we're going to discuss the reason for having getter and setter methods. Third, we're going to learn how to write getter and setter methods. And finally, we're going to see getter and setter methods working in a live code demonstration. Here we have a class student with two fields. The first one, student ID, is an instance variable, also known as a non-static field. And we know it's non-static because it doesn't have the word static here. Now, instance variables can have a different value for each instance of student. And that's what we want, because the student ID should have a different value for each student. Down here we have a static field, also known as a class variable. And we know it's a static field because it says static here. Now, this value mascot, since it's a class variable,
will have the same value across all instances of student. This variable belongs to the class. Now we can change the value, but it changes it everywhere. You'll notice that we haven't set a value for either of these variables. With local variables, we'd have to give it a value before we accessed it. But fields will set their own values if we don't set it for them. So this one is an int, so it'll automatically default to 0. This one's a string. A string is a type of object, and all object fields will default to null. These are marked private, and what that means is that we can access these fields inside the student class, but we can't access them outside the student class directly. Now, we do this because it makes it harder to accidentally change the value, but it means we need to have an indirect way to access them from another class, and we do that using getter and setter methods. So let's create our first getter method. You see we've named it getStudentID because student ID is the field we are trying to return the value of. It's got a return type of int. The return type has to be the same as the data type of the field we're trying to get. Non-static fields like student ID can only be accessed by non-static methods. So we have to make sure getStudentID is non-static. We know getStudentID is non-static because it doesn't have the word static in the method declaration. And we make it public so we can access it from other classes. Next, we'll create a setter method. This one is going to be setStudentID. We have to pass it a value, and we're going to use that value to change the value of the field student ID. So I've called mine new student ID. You can call it whatever you want. Of course, this parameter has to be the same data type as the field. It's a void method because we're not returning anything. And again, it's very simple. We're just setting the field student ID equal to our parameter new student ID. Now let's make a getter for the mascot field. So mascot is a static field. So traditionally we make getters and setters for static fields static. We wouldn't have to, but it makes it a little easier to access. So we're going to again say public static. Mascot is a string, so we're returning a string, and we're saying get mascot. And all we do is say return the value of the mascot variable. Next, we'll make a setter method for mascot. So we'll say public static. It's a void method because we're not returning anything. We're going to call it set mascot, and we need to pass it a new value. So we're making a parameter string new mascot, and we're setting the mascot field equal to the parameter new mascot. Next, let's compress this all down so we have a little more room. So here we've still got our fields. We've got our methods here, though we've hidden the bodies just so we have this room here. Now we're going to add a second class, the high school class. This would have to be in a different file, but for illustrative purposes, we're going to have it on the same screen. We're going to add a stack and a heap so we can trace exactly what's going on in memory. If you want to learn more about how stacks and heaps work with variables and objects, please click on the video in the upper right-hand corner of the screen. Next, we're going to add a main method to our high school class. And then our first line of code is we're going to declare a student Priya and have it point at a new student. So we're going to put the reference variable Priya on the stack, then it's going to point to a new student object on the heap. So you can see the instance variables are in the instance of the student class here, student ID. This defaulted to 0 because int fields default to 0 if we don't give them a value. And we notice our class variable we've got up here. And that's because we only have one copy of the class variable, so we're going to keep it separate. And the class variable is mascot. And since mascot is a string, which is an object, objects always default to null if we don't give them a value. Next, we're going to declare a new student variable, Andre, and have it point at a new instance of the student class. So we've added a new instance here, and again, it's got its own copy of the instance variable, student ID. Next, we're going to call the setMascot method from the Andre instance variable. Now, setMascot is a static method, so that means we could call it from Andre, we could call it from Priya, or since it's a static method, we could actually call it from the class itself, student. So we change the value of the mascot field to Duke. Next, we're going to call Andre.setStudentID. SetStudentID is a non-static method, so we would have to call it from an instance. We'd have to call it from either Andre or Priya. So we're going to set the student ID of the object Andre is pointing at to 1, 2, 3, 4, 5. Next, we're going to create a variable int Andre ID on the stack, and we're going to set it equal to whatever gets returned when we call getStudentID from the object Andre is pointing at. So Andre is pointing at an object with a value of 1, 2, 3, 4, 5 for student ID. So we're going to end up setting Andre ID equal to 1, 2, 3, 4, 5. Next, we're going to do the same thing with the Priya. So int Priya ID equals whatever was returned when we call getStudentID from the object Priya is pointing at. So the student ID for the object Priya is pointing at is 0, so we're going to set Priya ID equal to 0. Here, we're going to system out print line whatever gets returned when we call getMascot from Andre. So it doesn't really matter where we call getMascot from, because getMascot is always going to return the class variable mascot, and that's going to equal Duke for wherever we call it from. So this is going to print out Duke. Next, we're going to system out print line getMascot when we call it from the student class. GetMascot, as we said before, is a static method, so we can call it from an instance or from the class itself. So getMascot will again return the value of the class variable mascot, which is Duke. So this will again print out Duke. So there you have an example of tracing some getter and setter methods and seeing how it behaves in memory. Next, you're going to learn about overloading methods. Overloaded methods are methods that have the same name in the same class. Three important things to know about overloading methods. First, overloaded methods must have exactly the same name. Second, overloaded methods must have different number and/or types of parameters. Third, constructors can also be overloaded. Let's talk about the things that overloaded methods can't have different, what they can have different, and what they must have different. Overloaded methods can't have different method names. Occasionally a programmer will make an error and they will unintentionally give two methods different names. The methods will not be overloaded in this case. Overloaded methods can have different return types from each other. Overloaded methods can have different visibility. One could be public, one could be private. Overloaded methods could have different static or non-static values. Finally, overloaded methods could have different parameter names. The Java compiler needs to know which method is being called, so one of the three things must be different. First, the number of parameters, or the type of parameters, or the order of the type of parameters. For example, one method could have a string followed by an int, the other could have an int followed by a string. Let's look at some examples. We have three overloaded methods here. Output answer has no parameters. This output answer has one int parameter. This output answer has two int parameters. When we call output answer from the main method, we have one int argument. The compiler will use this to match it up to the appropriate method. Here it is. Let's look at another example. We have three versions of calculateAnswer. The first one has one int parameter. The second one has one double parameter. The third one has one string parameter. When we call calculateAnswer, we have one double argument. The compiler will use this to match it up to the correct version of calculateAnswer right here. Let's look at a third example. We have two different versions of computeAnswer. The first one has an int followed by a double. The second one has a double followed by an int. This call to computeAnswer will look for one that has a double followed by an int. Right here. Here's an example of two overloaded methods that have a lot of differences.
First, one is public, the other is private. The first is static, the second is non-static. The first has the void return, the second has an int return. And finally, the first has a parameter a, the second has a parameter z. This is all fine, however, there's a problem. Both have one Boolean parameter. This means when we call solve for answer with one Boolean argument, the compiler won't know which version of solve for answer we want. Let's correct this. The second one we're going to change from Boolean to int. Now we have one solve for answer with a Boolean parameter and another with an int parameter. Now when we call solve for answer with one Boolean argument, it knows which one to go to. Next, we're going to talk about constructors in Java. So what is a constructor? A constructor is sort of like a special type of non-static method that only runs when you first create an instance of a class. An instance of a class is also known as an object. So when you create an object, the constructor runs, and the purpose of it is to set up the new object. So let's look at this example. We've got a class robot and a class space station. We have a class variable, fuel source, and an instance variable name. And we have our constructor here. A constructor will have the word public, then the name of the class, then parentheses that may have nothing inside or may have parameters. So the first thing that happens is we set the field fuel source equal to electricity. The next thing we're doing in this example is calling a method. We can call a method from constructors. Random name. So what does random name do in this case? It just generates a random number from 1 to 3 and sets the name field to either Bender, HAL 9000, or Gort based on whether this is 1, 2, or 3. Okay, let's look over at Space Station. In our main method, we declare a variable of type robot called 1, then we create a new instance of robot. So we'll set fuel source equal to electricity, and we'll generate a random name and put it in the name field. Same thing with our variable 2 and our variable 3. Okay, next let's look at the situation where we have overloaded constructors. What overloaded constructors are is we have 2 or more constructors and the compiler differentiates them because they have different parameters. Now, in our example here, under factory, we create a new variable called 1 of type robot2, and then we create a new instance of robot2 and we pass the string r2d2. Now the compiler looks and says, okay, we've got one argument and it's a string, so we have to find a constructor that has one argument that's a string. And here's a constructor right here. So what it does is it says fuel source is equal to electricity, and then it takes the string that we passed in new name and sets our name field equal to the value of the new name parameter. Now let's look at this second one. We've got a variable named 2 of type robot2. We make a new instance of robot2, but we have no arguments here, so it's going to go to the constructor with no parameters. Now this is an example of using the this command. And what that does is, in this situation, this is going to call another constructor. So it's looking for a constructor that has one string parameter. So it goes to this one. It passes the string wall-e, so it'll set fuel source equal electricity, and it'll set name equal to new name, which happened to equal wall-e in this case. So let's look at another example where we can run into a problem overloading constructors. So now we have a class called Robot Confused, and we have a class called Alien Planet. We've got our 2 fields, and we've got 2 constructors. Now these constructors both have 2 strings. The strings have different names in the parameters, but it's 2 strings. This is a problem, because when we want to create an instance, we're passing 2 strings. Our compiler doesn't know, do we want to use this constructor or this constructor? It could legitimately be either. Robot Confused won't even build, because when the compiler tries to create an instance, it's not going to be able to know which constructor we want to use. Let's look at one more situation.
So we have a class robot3. Now robot3 has no constructor at all. Only in situations where a class has no constructor at all, Java will build us a very basic no parameter constructor. Here, when we declare a variable 1 of type robot3 and have it point at a new instance of robot3, since there's no arguments here, it'll call this very basic no parameter constructor it wrote for us. But it'll only do this if there's no other constructors that we've written. And again, it's going to be a no parameter constructor, so we can't pass any arguments when we create a new instance of it. Now you can see here, since it's a basic constructor, it's not initializing fuel source or name. Now fields will automatically initialize themselves if we don't initialize them. And it depends on what type of field they are. These are string fields, and strings are a type of object. So object fields, if they're not initialized, will always initialize to null. This is legal in this particular case because Java created this constructor for us. Next, you'll learn about the this keyword in Java. So what is this?
This contains a pointer to whatever object this is currently in. This, even though it acts kind of like a variable, it does not need to be declared. Also, this can only be used in either non-static methods or constructors. So let's look at it. We've got a heap here, and let's say we've just got some random object on the heap. And inside that random object, we've got these two variables, string x, which points to another object on the heap, int array y, which points to another object on the heap, and this, which points right back around to the original object. So there's three main uses for this. Number one, to specify a field over another variable of the same name. Two, to call another constructor in the same class. And three, to pass a copy of a pointer, reference, back to the current class. So let's take a look at these three uses individually. So first, to specify a field. Now I've created a couple of fields. One's static, one's non-static. And then I've created some methods. Now let's look at the printx method. You notice I've got a local variable with the same name as the field. This is legal. However, when we tell it to access x, it is going to give the local variable precedence. Now let's look at another example. Let's say we have a setter method. So we're accepting a parameter x, and again we have a field with the same name. Well, we want to change the field to the parameter's value. So to specify when we're talking about the field, we say this. So we're talking about this object dot x equals the parameter x. Same thing here, y. We're creating a local variable y, and we're saying this y, as in the field, equals y, the local variable. Second use is to call another constructor in the same class. So we've got this first constructor here, then we have this, and we're calling this other constructor here. If we use it in this sense, this must be the first line in the constructor. And the third is to pass a pointer, reference, back to the current object. So we made a random class, we'll call it this keyword 3. The first thing we do in the main method is we create an instance of this keyword 3. We called it an object, and we set that to equal new keyword 3. So an object is a new instance of keyword 3. So what happens is we have a new object. Then, since we've created this new object, this also caused this instance variable to be created, which is a different class called SumClass. And the name of the variable is another object, and that points to a new instance of SumClass. So what happens there is our variable another object points to an instance of SumClass. Now we're calling method 2 from the instance an object, and we go to method 2, and what this is doing is this is calling a method called SumMethod in the instance another object, and it is passing this, and this being the pointer, back to the original object. So we passed it, and this new object created a variable that points right back to the original object.
Next, you're going to learn about scope and lifetime of variables.
What is scope and lifetime? Scope determines where in a program that a variable can be accessed. Lifetime determines when a variable or object is created and when it is destroyed in memory. The scope and lifetime of a variable is determined by where it is declared, not where it is initialized. Sometimes we declare and initialize variables on the same line, sometimes we don't. Let's take a look at this class. We have our main method here, and we have four variables, a, b, c, and d. A, b, c, and d are all local variables because they are local to this method. Int a is declared here at the top of the method, and its scope is anywhere inside this method, and its lifetime is from where it is declared until the end of the method. Int b is declared inside this block of code here. So it's created when this block of code runs, and it's destroyed when this block of code completes. Here we have int c that is declared as part of this for loop. C is declared when we begin the for loop, and it is not destroyed until all cycles of the for loop are complete. Int d is created inside this block of code that's part of the for loop. Int d is created every time we run a cycle of the for loop, and is destroyed every time we end that cycle. Then it's recreated again when we run the cycle again. Let's take a look at this other class. We have a main method and we have another method. We're going to start tracing it out. So we're going to declare a, then initialize a. So that puts a and its value 3 on the stack here. Now we're going to call another method, and when another method runs, it'll run this code inside. Notice a becomes grayed out. That's because a is out of scope. It's not available in another method, since local variables are only available in the methods where they are created. However, it still exists on the stack, so the data's there, it's just not accessible right here. We finish up another method, and then we're back to our main method. Now we see a is now back in scope. Finally, we end the main method, so a is destroyed and removed from the stack. Next, let's take a look at this class. We'll start by looking at method 2. Method 2 has a parameter called name. Parameters are variables that are defined in the method declaration. We have to pass a value to them anytime we call the method. Parameters are created when the method runs, and their scope is anywhere inside the method. Their lifetime begins when the method is first called and ends when the method call is complete. Now let's take a look at this class variable here. Class variables are also known as static fields, and we declare them as static when we create the variables. Class variables are created the first time we use the class or we create an instance of the class. Class variables are accessible in all static or non-static methods in the entire class. The class and all instances of the class share one value for each class variable. So if you change it one place, you change the value everywhere. Now let's take a look at this instance variable here. Instance variables, which are also known as non-static fields, do not have the word static in their declaration. There is a different copy of every instance variable in every instance that we create of a class. So if we create 5 instances of the scope and lifetime class, there'll be 5 separate copies of the B instance variable, and they may each have their own values. Instance variables are created when an instance of the class is created and destroyed when that instance is destroyed. They are only accessible in non-static methods. So we can tell this is a non-static method because it doesn't have this word static there. This method is static, so we can't access instance variables.
That covers scope and lifetime of variables and concludes our topics on Unit 5. Thanks for watching. Please hit the like button and then leave me a comment down below. To see the next video, click on the image on the left side of the screen. To see the entire playlist for the series, click on the image on the right side of the screen, and to keep up to date on all the latest content, hit the subscribe button in the middle.